Out of three, it means we discussed about NICs, different cables. Now we'll see the devices. So you want to communicate, you have to connect to through some devices, right? It's different ways of communication for different purpose and different ways of communication, different types of devices we use. Okay. So different types of communication, different types of devices we use it. Okay. So what are those devices? In generally, hubs, repeaters, switches, bridges, routers, modems, wireless access point, your Wi-Fi routers, firewalls, um, IDS, IPS. Just I'm adding it. Later you can find it what it is. Proxy, proxy. Okay. So what is this proxy and all? You will find it. I'll give you some references also. You can try those things. But I will explain few. Remaining you will find it. Okay. I will tell where to find it also. Okay. Hub and switches are mainly used for a LAN communication. Hub is used for small networks. Switch is used for both small and large network. Small and large network means number of devices in the network. Okay, small number of devices network, hub is enough. I have 4 systems are there, hub is enough. Okay, but I have 10 systems are there, 20 systems are there, 50 systems are there. So compulsory need a switch. Okay, smaller to larger networks, you can use it. Small, large number of devices, you can use switch. Okay, small also. Okay. Hub don't know about anything MAC address, IP address, but switch understand MAC address. Okay, next. Repeater. Repeater is a kind of device. It is not in connecting two devices. Repeater is not used for connecting devices. Repeater actually repeat the signal. So you are sending a data for longer distance. So your source and destination, your destination is located more than 100 meters distance. Like it is in a 150 meters. Okay. But your UTP cable support up to 100 meters only. So what I will do it? So after certain length, maybe after 80 meters, 90 meters, I use a repeater. So the repeater repeat the signal means the V signal become normal signal now, normal strength signal. So then we can easily reach to the destination. Okay, that is a repeater. Repeat the signal. Bridging. Bridge is actually not a physical device. A bridge is like a software bridges are there. It is bridge between two different networks. Easiest example is Wi-Fi hotspot. Wi-Fi hotspot. You are getting internet from 4G, right? 4G chip, receiving your 4G internet from your mobile network, mobile data. 4G mobile data you are receiving. And you are sharing that data to other devices, right? To your laptop or maybe to your TV or maybe to other mobile phones, right? You are sharing it. Okay. Wi-Fi is different component and this is different part, right? You're bridging between them. You're bridging between them. So that is one example you can for our understanding. Okay. Bridge is a software bridge. Next is a router. Again, what is this router? So router used in both LAN and WAN communication. Router is inter-networking device. Router is inter-networking device. Meaning is it make a communication between different networks. Inter-networking means communication between different networks. Okay, the router is actually make a communication between different networks. Router will tell you how to reach the destination. How to reach destination. I am here. Okay, I'm here. I am accessing google.com, facebook.com, youtube.com, that's submarine.com. Okay, submarine to cablenet.com, whatsapp.com. I'm accessing a lot of things. But how my system was, how can I reach that destination? So in between, there's just several routers are there. These routers will tell you how to reach the destination. where is the destination, how to reach the destination, which is the best path to reach the destination. That is what router. So router three main important. LAN and WAN working. It works in LAN and it works in WAN connectivity. Inter networking means it make a communication between different networks. Router will tell you how to reach the destination. Next is modem. Modem. Okay, you want to connect it to internet. You're inside your private network, inside your intranet or your private network. All you are connecting with the switches only, right? Switch connectivity, general UTP cables or Wi-Fi connectivity. So different form of signals. The signal strength in the dial 100-meter signal, so it will strength is there. But from your home to outside of your internet connection is required. So you have to connect it via ISP only. Directly can't connect it to internet. You should connect through ISP only. ISP, Internet Service Provider, is located somewhere different location. How you will get connected to your ISP and ISP to internet. So for that one, we need a modem. For that one, we need a modem. So modem use it to connect to internet via ISP using telephone cable or fiber optical cables. Okay. Next is wireless access point. What is this wireless access point? Wireless access point is like you have a wireless type of devices. Okay, you have wide type of devices to connect in the LAN. We need a hub or a switch. But you have a wireless type of like a laptops, mobile phone, your smart TVs, your tablets, right? Wireless type of connectivity. So how you can able to connect using wireless access point. Okay, wireless access points are used to connect wireless. It provide wireless type of connectivity. Wireless type of connectivity. So it is create WLAN, wireless LAN. Okay, wireless LAN. Wi-Fi router is again, generally we are using Wi-Fi router only. We are not using any switches, hubs or routers, wireless access point. We are not using in your home kind of. So in your home, you don't see that those things. But still you are getting connected. How? Because of wireless routers, Wi-Fi routers. This Wi-Fi router is mix of your modem. Okay, it is act as it is a modem, it is a router, and it is wireless access point, and it is becomes switch or hub kind of stuff. Okay, itself it is like that. So this is a wireless. Next is firewall. Firewall is used to protect your network from external attacks. IDS and IPS. Even if you have a firewall, you want to you are protecting your network from any unauthorized accesses. So you are using a firewall to protect your network from any unauthorized access from external. But still, there is a possibility of exploiting into your network. So packets are came into your network by some exploitation, some loopholes, right? You want to find what is that packet without having certain headers or some source destination kind of stuff. You can detect it using a IDS devices, institution detection system. Okay. Next one is IPS, prevention system. It will prevent from that exploitations are happening. Okay. And proxy is not exactly a device. Proxy is a service. Proxy means, simple to understand. Proxy nowadays is very easy to understand. For example, you have seen in YouTube, a lot of people put it now. Proxy interviews. Interior is correct person, but a person who is giving an interview, the candidate. So his face is same, but someone is giving voice in the background. Okay, some voice and as well as other things. Okay, so voice and see, instead of the actual candidate, someone is giving an interview, right? Like a proxy interviews. Okay, that's very dangerous. And now people are easily caught in this proxy interviews. Very dangerous one. Okay. Yeah. What is this proxy? Instead of your IP address, there is a proxy server will send the packets with a different IP address, different IPs. It's with this name, it will send it. Instead of your IP and your identification. With a different identification, you have different IP address, it will send packet. That is proxy. But all these three things, you should find it. So I will tell you where to find it also, and you tell me what it is. Okay. So go to YouTube. These are all fake videos. So I open this one. I don't want this. I want to go to this part. This is guys. This is animated videos. It's not my channel anyway. Okay. So don't worry. I'm not asking you to subscribe also, but go to this channel. So there is a lot of videos. Search for your voice or IP. See, or modem and router differences, switch hub router differences, Wi-Fi router and wireless access differences, layer to layer 3 switches, cables, Ethernet cables, okay, network connections, DNS, okay, different things are available. Even you can find about the firewalls, okay? Just network. This one also you can find. Firewall you can able to find, IPS, IDS you can find, proxy, reverse proxy you can find. What is VPN you can find here. Okay. So find out. So when you got a time, so please go through it, LAN, MAN, subnet, private IP, public IP, all are straight questions only. MAC address, what is default gateway, subnet mask. Okay. So like this. So what are we said? So we'll try to find from here, see proxy server and what is this firewall. Okay. Purpose of firewall. HTTP and HTTPS differences. What is CSMA by CD and CSM by CA? What is LAN, MAN, CAN, PAN, HAN kind of stuff. Okay. Find out. So it's only 5 to 10 minutes. Max to max time is 10 minutes only maximum limit. So mostly it is around 5 to 10 minutes only. 5, 6, 7 minutes like that only. Not even a 10 minutes. So find out all these things related information. Then note down the important points in it and first understand, then note down the points. Okay. Okay, guys, understand this. I will share 1 or 2 videos from here also, so then you will understand which channel it is instead of sending center channel part. I just put a link, it will some process. Okay, so here it is. Hub, switches, repeaters, and routers, modems. These things I have given information in our notes. We'll see one by one. Guys, hub is look like this one. This is a device of hub. Okay. It's look like this one. Generally, hubs are this is small port numbers only. 8 port number, 16 port number, 4 port numbers only. When you want it, always type like this networking hub. Networking hub. Okay. Maybe it is hub or SH, you have to correctly, you have to find it. So networking hubs. Okay, these are the. And hubs are non-intelligent type, means there is no separate processing is not there for hubs. Just you have to turn on the hub and you can start it. Okay. Next, it is not understand any of your MAC address or IP address. So it won't take your packet and processing your packet is not there. And it's won't check any of your MAC address and IP address. It take the packet and forward the packet. That's it. Hubs used in LAN communication. Hubs are suitable for small networks. As per OSI layer model, it is a layer 1 device. It's an example of physical layer 1 device. Hardware example is hub. Hub broadcast packets to every device in the network. So I'm not having more time. It's already 12:29. Okay. So just I'm trying to explain guys from here only. If you see, this is APC, BPC, CPC, D, E, F are connected to one single hub. Okay. So A want to send a packet to B. A want to send a packet to B. The packet is sent to the hub. Hub receive the packet and broadcast the packet to every device in the network. Every device in the network. Not only one time, always. We want to send a packet to E. So B to this port, switch hub and hub to D and as well as E as well as F and A also. It means not only it is sending to the destination, also send to the everyone. Other devices will drop the packet and the actual recipient packet will be accept the packet. Okay. So it is keep on sending. That's why it is suitable for small networks. Why? Because of more number of devices means, okay. For example, C is receiving packet from A as well as B also. Both packets are not belongs to C. A to B communication. Packet is belongs to B, but C also getting same packet. Okay, or B to D communication. So not only for D, if the packet also sent to the C, means C is receiving B's packets, D's packet. Okay, so it means unnecessary traffic is increasing because of these traffics and same traffic it is happened. So collisions will occur in the data. So the more number of collisions, data packet loss is also occurs. That's why hub is suitable for small networks. Hub is layer 1 device, physical layer. Importantly, hub broadcast packets to every device in the network or every device to all connected devices. What is meant by broadcast? Sent to all devices. Okay, all connected devices or all devices. Hub is broadcast packets to every device in the network or all devices in the network. Okay, all connected devices in the network. Broadcasting. Hub broadcast packets. Send everyone. Send to everyone. That is hub. Guys, understand hub. Any doubts in hub? Next is repeater. Okay. What is the repeater? Once again. What is a repeater? Repeater repeat the signal. Repeater repeats the signal. See, this is the incoming signal. It is become after certain point, certain distance, the signal become weaker. But still I want to communicate, I want to reach certain distance. So I use a repeater, then repeater again restructure the signal, means as the signal will be generated, so we'll receive the proper signal here. Okay, this is how the repeater is there. So one side of one cable is incoming and this is like this. This is a repeater. Sometimes you can use hub as a repeater also. Nowadays, you may not able to see these repeaters. Maybe it is there, but we are not seeing directly, right? So it may be somewhere it is used. But we can see this kind of Wi-Fi extenders. Best example is Wi-Fi extender also like a repeater. See your Wi-Fi router, actual Wi-Fi router and your device is longer distances. So you are not receiving proper signal or no signal at all. Because they put a Wi-Fi router in your home hall, but you are sitting in some other room, which is there, you are not getting proper signal or no signal. So you have to check it between these devices, between your Wi-Fi router and your device. So check it where the signal is actually are getting good or okay. Then place the Wi-Fi extender. So you will connect it through Wi-Fi extender to your router and your router is receiving through this extender. Okay. So Wi-Fi extender is like a repeater. So it will receive a signal from your Wi-Fi router and it will resend again to the your distance. So it's like a repeater. Next one is you are not really connected to your Wi-Fi extender. You are going through your extender. You are not connecting an authentication or authorization your extender. You are actually connecting to your Wi-Fi router only. What is the right only? Guys, understand what is repeater, Wi-Fi extender?
Yes, sir.
Then we are going with the switch. Switch has some intelligence, means some processing is there in switch. Switch received, whenever it is switch is receiving a packet from the source. Okay, for example, A send a packet to B. So in that time, A send a packet to the switch arm. So what switch is doing? Understand its MAC address. Incoming packet, MAC address. It check the incoming packet. In there, it take the MAC address and map to its port number. So switch can understand MAC address. So then it will learn the MAC addresses of connected devices, means from incoming packets only it will understand its MAC address. Okay. And it will maintain the MAC address table. Switch is maintaining MAC address table. Switch used for LAN communication. Switches used for LAN communication. Switches used for LAN communication. Okay. Switches, as per YSA, it is layer 2 device. Data link layer. Layer 2 means data link layer, which is layer 2 device. Switch used for both small as well as large networks. Large number of devices we can use in the switch connectivity. Okay. This is how the switches are there. Same thing, networking switches. Search in a Google networking switches, you will find different switches and how it is look like. Okay. Switch initially do broadcasting, but later it is unicast using MAC address table. Of course, there is small explanation also there. We'll see that explanation. So this is APC, this is BPC. For example, A send a packet to B. Okay, A send a packet to B. So what happened? The packet is sent to the switch port number 1. And what is switch will do? Switch will do, it take port number 1 and it check the what is the MAC address, incoming MAC address. Guys, when you are sending a packet, the packet contains your source MAC address, your source IP address, and destination MAC address, and destination IP address. So while you are sending, you are telling about your source MAC address. So it will learn this your source MAC address and put the source MAC address on the MAC address table. Then it is what is the destination? Check the destination MAC address. So where is the destination MAC address? It will check in the MAC address table. So it does not find any BSPC MAC address here. For example, it will broadcast to everyone. It will broadcast to everyone. It means whenever incoming packet came to the connected device, so it will learn its MAC address while they are communicating. Learn its MAC address. Okay, it will put that port number and MAC address on the MAC address table. And you check the destination MAC address. Again, check the destination MAC address against the MAC address table. It finds destination MAC address in the MAC address table and the port number. It will send that packet to the destination only. For example, I want to communicate it to CBC. C's MAC address is already given. C's MAC address is available. Then what it will do, directly send to the port number 7 and C will receive the packet. So what switch is doing? So it will take incoming packet and check its source MAC address and it map to its port number. Switch port number is 1, MAC address is A7. Then there are communicating. And it check the destination MAC address. It check the destination MAC address, check in the MAC address table. Okay. So if destination MAC address table is MAC address, its port number is found, then it will forward the packet to that port like that. That is called a unicasting. If in case the destination MAC address, its port not available in the MAC address table, switch broadcast the packet, means send to everyone. And this is how it is works. Okay. Switch verify the MAC address table against for a destination MAC address mapped, which is mapped to port number of switch. If it is fine, packet sent to the port. That is called unicasting. Okay. So here also given A send a packet to B, but the same packet is sent to the everyone. Because it not find any B's MAC address in the MAC address table. Next. And it learn the A's MAC address and map into MAC address table with the port number 1. Okay, once it is learn the MAC addresses, so it will do start unicasting. Okay, so first it will check the MAC address table. It find unicast, not find broadcast. So because of this, you are not sending packets. Because of this, the packets are not sending to other devices. So we are doing unicasting means other devices not unnecessarily they are not getting your packets. Okay. So number of traffic is reduces, number of collisions will be reduces, less packet data loss. So this is about your switch. Again, difference between hub and switch. Hub is layer 1 device, switch is layer 2 device. Hub and switches used in both on LAN communication. Hub used for a small networks. Switch is used for a large network, large number of devices. Hub always broadcast packets to everyone. Switch maybe initially it will broadcast the packets, but later it is unicast packets using MAC address table. Okay, when devices are communicating, so it will learn the MAC address of source system and map it into the MAC address table. And it check the destination MAC address of the packet and check in the MAC address table. If it is fine, unicast, not fine, broadcast. Okay, such as used in both small and large networks also. Okay? It understand MAC address. It maintain MAC address table to unicast the packets. And there is a layer 3 switches also there. What is this layer 3 switch? Layer 3 switches, not only layer 2 functionality, it has a layer 3 function, means IP addresses, inter VLAN routing, VTP creations, VLAN management. We can do with the layer 3 switches. But layer 3 switches do not have WAN interface like a router, but it is act like a router within LAN, not to WAN connectivity purpose. Within your organization, within your private, so you can use it, but not for a WAN connectivity. Direct WAN connectivity is not there. Two more devices to go. Okay, then we'll take a lunch break, and so Sir will tell about afternoon. Router is a in internetworking device. Router connects to our more networks. Router make a communication between different networks. Router makes communication between different networks. Okay. Router works with a logical addressing. Switch works with a MAC address, physical address. Router works with a logical address. Different logical addressing is there, including IP address, SPX, IPX, replica kind of stuff, but it is router use logical addressing. For us, it is IP address only. We are all using IP address only. Okay. So router use intelligent device. Router is intelligent device. It understand and marks with a logical addressing, including IP address. Findings. Okay. So router make a connectivity between different networks. Router works in both LAN and WAN communication. LAN communication and WAN communication. See this? If you see this picture, this bottom, this is a one LAN. Okay. And these people want to communicate other network. So they have to communicate through these routers only. And these routers are in different places. So they are connected using WAN connectivity. So it means router is connected to LAN as well as WAN connectivity is also there. So it works in both LAN communication and WAN communication. WAN means wide area network connecting outside of your network to through like your other branch office, head office. You are connecting through WAN connectivity. And WAN over the public, that is internet, that's a different point. Okay. Router comes under YSA model layer 3 network layer. So network layer hardware example is router. So switch is layer 2 device, router is layer 3 device. Okay. Next. What is router, router, what it is? Root. Actually root means path. Router shows best path to reach the destination. Router shows best path to reach the destination. Router uses routing table to know how to reach the destination. Routing table. Okay. Router will tell how to reach the destination. Okay. But how it will tell based on its routing tables. These routing tables will be created manually. I can create my own routing table inside and tell how to reach this specific network, which way, how to go. What is routing means? How to reach a specific destination and which way you have to send packet. That is called routing. The routing tables contains this information. This information can be added manually, you can add it, or automatically this information is created. Means the tables are created, routing tables are created automatically also. Automatically means by using some dynamic routing protocols like RIP, AGR, PYSP, FEGP kind of stuff. So these protocols are used to generate routing tables from other routers. Okay. Again, Switch and router, guys. Switch is works with the MAC address. Router works with the IP address. Switch used in LAN communication. Router works in both LAN and WAN communications. Switch connects one network. It make one network alone. Okay. But router make a communication between different networks. It's internetworking device. Router is internetworking devices. It works in both LAN and WAN communication. Routers will tell best path to reach the destination. Okay. Switch maintain the MAC address table to send packet to particular destination. The MAC address table is very helpful for unicasting. The switches use MAC address table. Router use routing table to reach the destination. Router use routing tables to reach the destination. Guys, understand router difference, MAC switch and router difference?
Yes, sir.
The last one, okay, modem, modulator and demodulator, modulator and demodulator. So when you are sending a signal, our signal is generally digital form of signal, electrical signal it is, but that's the length it cannot able to travel, and different media type of connectivity is there. Okay, different media type of connectivity. We are sending data over something like a, so we are all different individual connections. Your laptop, mobile phones, desktops, TVs, all individual connectivities. But how we can send each connectivity data over the internet to connect it to internet, right? It's very difficult. So then we need a device called a modem. From your modem to ISP get connected. So in a modem, you're already configured with username, subscription username, password, and connection type in your modem. So then the information send to the ISP. ISP verifies your user ID, password, and connection type, and what is your subscription plan. Based on your subscription, it allow you to connect it to internet. It allow you to connect it to internet with a dedicated bandwidth speed, what based on what subscription you have taken. Okay, so modem is used to connect internet. Okay, it make a connectivity to ISP. Through ISP, you can able to get access internet. Okay, so sometimes these routers, these Wi-Fi routers are being built in modems, switches, wireless access point, and other things. Okay, so this is the one. And for batch, every batch, I will tell about this SOHO configuration. What is this SOHO part for every batch? But for you, I didn't, we didn't discuss that. Why I didn't discuss? Because I want to tell separately after discussion about some devices, then we'll really understand their purposes. Okay. If you have time, read about these devices also. You can see. Okay. Now that's it for today. So tomorrow we'll see the remaining part. Okay. Any doubts? Any questions?
No, sir.